Welcome back to this series of videos where we are learning how to use Flexutils tools to analyze our conformational landscapes. In today's tutorial, we are going to learn how to use the Annotate Space tool. Before working with this tool, keep in mind that in order to run it, we will need to have first an execution of a program that is able to estimate a conformational landscape. For example, this Hexagon box here, or CryoDragon, 3D Flex, Cernic 3D, etc. And then we need to take this landscape and also perform a dimensionality reduction using the dim red space protocol inside the Flexutils plugin. Once we have that, we can run our annotate space. Basically, annotate space will take the reduced landscape and it will show a representation in 3D, which is interactive, in such a way that we are able to rotate the space, click any point, and get automatically different conformations, annotate different regions of the landscape, and also checking all these different conformations as 3D volumes. In order to run it, we need to go here to the left menu of Scipion. We go into the View tab, and here you have different ways of grouping protocols inside the Scipion. We're going to choose the one saying Flexibility Hub. And once we are in the Flexibility Hub tab, we can go to Data Analysis, and here we have the Annotate Space protocol. We will double click on it, and the protocol form will appear. As you can see, we have only one required parameter, which are the particles to annotate, and this will be the particles coming out from the dim rate space protocol. I am going to find the particles I want to annotate, which are going to be this one here. I select them. And now I will click on Advanced to show other parameters of this protocol. The additional parameter is this number of particles to associate to selections. As you will see later, there are different ways to associate particles to the different points that we are clicking in the landscape. For example, if we click a given point in the landscape, we can also associate to it the closest points that surrounding the point that we have just clicked. And this is a parameter that we are going to use to determine the number of points to associate. As I said, you will be seeing later on what is the meaning of this when we are creating the outputs. The other important parameter is the GPU's IDs. There are some programs that can take advantage of the GPU to generate all the volumes much faster, and in those cases you can set the GPU ID to the GPU uses to yes, and you can also select the ID of the GPU that you want to use. If you are not sure if your program you're going to be using can use GPU, you can set it to no and rely on the CPU to perform all the computations. Once we are happy with the protocol form, we can click on Execute to open the Annotate Space window. Once the window is open, you will be seeing this Napari-based viewer showing different panels and also the conformational landscape that we have just obtained using the dim red protocol. Before analyzing the landscape, let's see what are the different panels that we have in this viewer. The first panel is the main top window here, which comprises the window where you have the conformational landscape and also some visualization options for this conformational space. From the conformational landscape, you can use the wheel of the mouse to zoom out or zoom in, and also you can left click on the landscape and drag the mouse to rotate the 3D space. This allows us to get different points of view of the landscape and to understand better what is going on with our conformational space. Regarding the configuration options here, you can also select the axis that you want to represent in the conformational space. Depending on the options that you have chosen on the dim red protocol, you can have a different number of dimensions for the dimensionality reduction. By default here, we are showing the first three axes of the dimensionality reduction method. But if you have more, you can go here, click on, for example, dim 4, if I have it here, and you can see any combination of axes that will be automatically updated in this window here. Also, we have this landscape ball sigma, which is related to these representations showing kind of densities in the conformational space. And you will be seeing later on how we can modify these densities to see finer features of the landscape or broader features. The extract selection to layer also will have an important role later on in this tutorial. And then the other parameters are advanced parameters that will be covered in a different tutorial video. The next panel is this panel here that we are finding to the left of the conformational space window, which has different configuration options for the current activated layer in Napari and also the layer manager of Napari. The layer manager is very, very useful because you can see all the layers that you are creating while you are annotating the space. By default, 3 different layers will appear, which is the landscape, which are these white points that are appearing here in this window, the landscape ball, which is this representation of densities that are computed based on the white points, and this landscape ball, which is hidden and is not useful for the analysis. The layer manager is very, very useful. For example, you can click on any layer, and as you will see, once you click on it, it will become blue color, meaning that this layer has become the active one. This activation of the layers will be a very, very important feature later on this tutorial. Also, you can double click on any layer and you can change the name, which is also useful when you are annotating different regions of the landscape and you want to differentiate between them. So when you are, for example, running again the viewer some time later, you can very easily understand what you were doing the day before. If we click on this landscape here, we can use the eye to change the visibility on or off. And also we can modify, for example, the color of the points or the sizes of the points. To do that, you make the layer active by clicking on it. You left click on the window of the conformational space. I have clicked just to show you. I can now rotate it. And now if you click on Ctrl plus A, all the points in the layer will be selected. And once they are selected, for example, we can increase the point size to, for example, 5. Let's make the points again small. Okay, and now if we want to deselect the points, we can just click on the viewer, click on Ctrl plus A, and now we can just deselect all the points that we have selected before. As another example, let's go to this landscape ball layer, and here you can also change, for example, the color map of these densities. For example, we can use plasma color map, or we could use HSV, and you can get different representations of the density. I am going to go back to the first one, which is Inferno one. And also, as I said before, we can modify how fine these densities are using this landscape box image slider we have here on the right panel. Let me put here a different number, for example, 5, and click enter. And now you can see that we are not really seeing many things here. Something has changed, but we are not able to see the densities properly. And this is because the viewer is not automatically handling the contrast by default. So when we are changing these values, the contrast is not updated to be consistent with the new values. To do that, we click on the landscape ball layer, and here you have an auto contrast option. You can click on once to just change the contrast this time, or continue so that when you are modifying this layer, you are changing the contrast all the time. Now, of course, we are seeing better the densities, but they are still kind of dim. So we can try to improve the visualization of these densities. And for that, we can use, for example, the contrast limits. If we increase the contrast limits, now we can reduce a little bit the background, this purple background, the densities. And we can also decrease a little bit the upper contrast to make the other densities looking more bright. And now we are seeing much better what are all the finer densities computed by this program. This could be useful to identify, for example, how these different regions are connected, which regions are more populated than others, and probably identifying interesting conformations in our conformational landscape. Okay, so now that we know how to modify the conformational landscape and improve its visualization, how can we select points here so that we can check the different conformations that the initial program that we have used have found? Well, to do that, we need to use the last panel in the viewer, which is this panel at the bottom. The first panel has 2 different tabs. One is the map view. You will be seeing later on what this map view does. For now, let's click on the menu tab. And this tab has some important buttons. being the first one, the Save Selections button. As you will be seeing later on, by clicking on this button, we can save what we have been doing up to that point so that the Scipion can register all the outputs for us. The other one is a text box here, where you can write any number going from 0 to, in principle, the maximum number of particles that you have in your dataset. And this will allows us to perform clustering of this conformational space to, for example, extract automatically different regions that can be detected by a clustering algorithm. Let me put here, for example, a small number like 5. And now we can compute clusters based on two different methods. First one is k-means. We just try to split based on this number of clusters we have put here, the space, so that we can have uniform distributed clusters, or cluster along PCA dimension, which will perform a PCA, then take one of the dimensions of the PCA. You will be seeing later on how to change them, and then cluster along that PCA dimension. For example, let's click on Compute K-means. Now you are seeing that the landscape has been clustered, and we are seeing here the cluster representatives. These are the center of each of the 5 clusters that the program has found. Also, you will be seeing that in the layer manager, many different layers have appeared. The first one is this k-means layer, which are these points that we are seeing here in the landscape, the cluster representatives. We can toggle the visualization of them or on off. And then also we are seeing here some layers containing all the points that have been associated with a given cluster. For example, if I click on the visibility, if I toggle the visibility of cluster 5, now I can see all the points that have been associated with cluster number 5. Similarly, if I do this for cluster 3, now I am seeing all the points that have been associated with cluster number 3. Let's try now to perform again a clustering of 5 groups using the cluster along PCA dimension. To select the PCA dimension that is gonna be used to perform the clustering, you can use this drop-down menu here. You have next to the box where you can write the number of clusters you want to use. And here we are seeing just 2 dimensions. This is because in the dim red protocol I executed before the annotate, I have just selected to reduce to 3 dimensions. But if I have a larger number of dimensions, here I will have more dimensions in the drop-down. For example, if I select the first dimension and I click on cluster along PCA dimension, now I am seeing here the points associated with clustering along the first PCA dimension. We should note here that the dim red method I have been using before is not PCA, it's UMAP. So what we are seeing here is the UMAP representation of the landscape in 3D. But here I am asking to show points along the first principal component. Of course, UMAP and PCA are not compatible with one another, and that's why we are seeing that some points become very clustered here. Then we have no points here in this region in the middle. This is just because of the non-linearities of UMAP compared to PCA. But again, this is really computing the clusters in the first principal component. Similarly, if we click on, for example, layer 4 and we toggle the visibility, now we can see all the points that have been associated to cluster number 4. Okay, let's increase the number of clusters and let's click on Compute K-means again. Okay, now here I have all my new clusters. And now instead of seeing the clusters, I really want to get the volumes that are coming, for example, from all these representatives. How can I do that? Well, there are 2 different ways to do that. The first one is we go to the layer manager, we look for this k-means layer here, we make it the active one by clicking on it. Now it is blue, so it is the active one. And now we go to the layer controls and we look at these buttons here at the very top. These buttons allows us to interact with the conformational landscape in different ways. The default one is the magnifier, which is the one that allows us to zoom in, zoom out, rotate the landscape, and so on. The other one is for selected points in the landscape, which is the one we are going to be using now. And later on, we will be seeing this plus sign here, which is a tool for adding points. And you will be seeing how we can also create our own points in the conformational landscape. For now, let's click on the selection tool. Once the tool is clicked, I can hover over the points of the currently active layer, which as you can see is the k-means layer. And you will be seeing that this blue circle appears on top of the point. If I left click on the point, I have just hover. Now a conformation appears here on the bottom panel. This conformation, you can play with it the same way you can play with this conformational space. You can zoom in, you can zoom out, you can rotate it, and now you can analyze the volume coming from this specific conformation here. For example, if I click on cluster 1, now you are seeing a different volume. This automatically updated based on the conformation of this specific point here. We can also modify the visualization of the map. To do that, we go to the bottom panel, we go to these tabs here saying menu and map view, and now we click on map view. And here you have all the controls to modify the visualization of the volume. For example, we can change the opacity, we can play with the contrast limits to see better different regions of the volume. This gamma controls also the intensity, the brightness of the volume, and with this we can improve the representation. We can even render the volume in different ways. For example, we could use an isosurface, which is similar to what Chimera X does. However, this becomes very, very slow if you are using a remote desktop. In my case, I am using a remote desktop, and that's why we are using by default minimum intensity projection. But if you are using a local machine, probably you want to try also the isosurface. Great, so now we know how to click on any point in the landscape and automatically get a conformation here. What if I want to get not just one conformation, but all the conformations at the same time and do, for example, a morphing of all of them to understand much better what is going on with all the conformational changes? Well, to do that, instead of using this viewer, we can use the connection it has with Chimera X to open all these clusters at the same time, the representatives, and then perform a morphing of all these volumes automatically, or perform any other visualization that we want to do in Chimera S, which is much more advanced than the one that we are provided integrated with the viewer. To do that, we go again to this bottom panel, we go to menu, and we are going to be using this button here saying Morph Chimera X. Before going into the morphing, we are going to be also taking advantage of this active layer that we were talking about before to tell Chimera which layer should be morphed. So for example, if I click on the layer k-means, now it becomes the active one. If I click on morph Chimera X, I will be morphing the points that are stored in this k-means layer. What if I click on cluster number 2? Well, as you can see, there are many, many points here, which means that we will need to store a lot of number of volumes, morphing them in Chimera, and this will become very, very slow, or even it may crash your PC. That's why there are some names in these layers, like for example, Dove starting with cluster, that will not be morphed in Chimera. Even if you try to click on the morph Chimera S, they will not be morphed. This is just to prevent any unwanted scenario. Also, there are some layers whose names cannot be changed. For example, this cluster 2, if you try to change the name, it wouldn't be able to be changed. For example, if I double click on the layer and now I change the name to, for example, points, you see that the change of the name is rejected and it appears again as cluster 2. Something similar happens with the k-means layer. Again, if I try to change the name, it won't change it. And this is because this name is going to be used to save the points inside the Scipion in a specific manner. And something similar happens with the landscape and landscape ball. You cannot change the name of these layers. And also you're trying to perform a morphing of these layers here. The viewer won't let you do that. So for now, let's toggle off the cluster 2. Let's click on k-means to make it the active layer. And let's morph it using the bottom morph Chimera X. And you will see that the Chimera X window will appear. showing all the volumes that we had in this k-means layer, and it will perform automatically a morphing for you based on the salesman's algorithm, which is trying to find the closest path connecting all those different points, so that you can get an idea of all the different motions that are present in your layer. For example, let's go to the morph volume. Let's decrease the threshold so we can see better the map. And now, if we drag the slider, you can see all the different conformational states found by this program. Once you are happy with your visualization, you can just close Chimera X. And again, if you want to perform a new morphing or morph again this layer, you can just select the layer and click on Morph Chimera X, and the window will appear again for you. Okay, now we know how we can perform clustering of our conformational space, how we can click on the different clusters to see different conformations here, and how to morph them with Chimera X. But what if now, instead of performing a clustering, I want to click or select specific points in the conformational space that I am very, very interested in? For example, clicking a point here to check what is going on with this region of the conformational landscape. Well, we can also do that with this viewer. And before doing it, we need to define a new layer here in the layer manager. Doing this is very, very simple. We go to the layer manager, we go to these top buttons here, and we click on this one that is looking kind of a point scatter. And after clicking, it will create a default layer called points. In this case, we can modify the name of the layers that we are automatically creating. For example, here we can change the name to my custom layer, for example. And now we have modified the name. And this is useful in case, as we said before, we want to have different layers corresponding to different conformations or different regions of the landscape. Okay, now how can we add points to this new custom layer we have just created? Well, to do that, we need to first make it the activate layer. You will see that this is the active layer because it's again in blue. We go to the layer controls. We go to these top buttons here. And now we're going to click on this plus sign that says add points. Once this button is active, if I go anywhere to my landscape and I click on it, you will see that a new points appear and the conformation is automatically updated in this viewer here at the bottom. Okay, this point is looking kind of big, so let's make it a little bit smaller. For example, put it size of 4 so we can see it better. And for example, we can also change the color. Let's say we want to use a green color for these points here. Great, so now I have clicked on this point here, but how do I know if I have put it exactly on the place I am interested in? Because remember that this conformational space is 3D, which means that by clicking, we know that we have placed it very, very well based on this view, but probably the depth of the point is not the correct one. Well, we can modify the position of the point very, very easily. To do that, first, let's rotate the landscape so we can see a perpendicular view of it. For example, we click on this magnifier. Again, we rotate the landscape. And yeah, as you can see, I was trying to click here, but the point has been placed around here. How can I move the point so it appears exactly in the position I am interested in? Well, again, we go to the point, to the layer containing the point, we make it the active layer, and now instead of adding points, we are going to use the select points tool. We hover over the point that we want to modify. Now we left click on it and we drag it while keeping the left click clicked. And we place it on the position we are interested in. And as you can see, as soon as we release the left click button, we will be placing the point. And again, the volume that we have here will be updated with the new confirmation of that new position. And now by rotating the landscape and moving the point, we can refine the position, as you can see here, to place it exactly in the position I am interested in. Great. Now it is more or less in the position I want. Could be a bit more center, but it's giving me an idea of what is going on here, right? And of course, I can add as many points as I want. I can create as many layers as I want. And with this, we can also analyze all these different conformations. Great. Now let's see how we can select manually points in our landscape. As you can see, we have a small transition now. I have just toggled off the visibility of different layers just to have the landscape layer so we can see better all the selections. This is not needed. You can, of course, have all the layers toggled on when you are selecting points. The only requirement is that you will be selecting from points from the currently active layer. In my case, is the landscape layer, but if I make, for example, k-means the active one, I will be selecting points from this k-means layer instead of the landscape layer. For now, I will make the landscape the active one, and we have two different ways of selecting points from it. The first one is we go to the layer controls here. We use the select points tool. And if I left click anywhere and I drag the mouse by keeping the left click hold, I can draw a rectangle and use that to select the points. You will see that the conformation is updated based on the center of all the points we have selected to get an idea of the conformation of the points that we have selected. This will be the first way. But what if I want to select, for example, this region here, and I want to be very, very, very precise, so I am not selecting any other points? Well, as you can see, with the rectangle, it's kind of hard because we are making very, very sharp edges. Instead of using this tool here, let me use Control A to deselect all the points. We can use the implemented lasso selection tool in this viewer. To use it, we can just click and hold the mouse wheel. And now if I start drawing, you will be seeing that we are defining a lasso tool that allows us to select very, very precisely the points I am interested in. And if I release the mouse wheel, now I have just selected these points over here. This is great. What if now, instead of just selecting these points, I want to select these points plus these points over here? Well, to do that, we can also use the lasso tool. We just need to hold the control key in the keyboard. We keep it hold, and now again we hold the mouse wheel. We draw the region we are interested in, and if we release, we are selecting these two different regions here. One of the problems of selecting points in 3D is that we are selecting all the points that are collapsed in this view. This means that if now I rotate the landscape, as you can see, I am selecting all these points here that were collapsed in the previous view, but probably I am not interested in those. So then how can I refine my selection to remove all these points here? Well, for this, we can also use the lasso tool, but instead of holding the control button, now we will be holding the alt button. Let's give it a try. Let's hold the alt button in the keyboard. And now let's define a lasso covering the points that were selected we are not interested in. And as you can see now, we have removed all these points from the selection. And if I rotate, now everything is looking much, much better. Okay, now the points are selected, but we don't want just to have them selected. We want to extract them to a new layer. To do that, once the points have been selected, we go to this panel to the right, and here you have the extract selection to layer. We can click on it. And now you see in the layer manager that appears a new selected points one layer here, which if I toggle off the landscape, corresponds to the points that we have just selected. And again, we can modify the name to give it a specific name, saying that we want to have this as, I don't know, conformation number one, that we believe is very, very, very interesting. Great. With this, we have seen all the different ways to select points in the landscape, select specific regions by creating custom layers, using the different clustering tools, Okay, so now we are happy with our annotation. How can we save it into a Scipion? Well, it's actually very simple. We click on Save Selections. Once you have clicked, probably you can pause the video a little bit before. You will be seeing here some squares that are moving in blue. While these squares are moving, it means that the program is saving all the different layers we have just created. Once this square is not here, it means that everything has been saved. And now to register everything in Scipion, we can just close the Napari window. And now this window will pop up saying if you want to save the output to a Scipion. If we don't want to save it because we want still to do some refinement to all the things we have been doing, we can say no. If we are happy with the output, we can click on yes. And now a Scipion will start registering the output. After some time, you will see that the protocol changes to interactive mode. Now we can click on the summary tab here at the bottom of the Scipion, and you will be seeing that we have two different outputs. The first one is a set of classes, which has all the different volumes that we have created, either by clustering or by manually selecting points in the landscape, and also by selecting and extracting points to a given layer, and also a set of volumes here, which has the same size as the set of classes, and this one only has all these volumes stored. What is the meaning of this? Okay, let's right click on the set of classes. Let's use the Flex Data Viewer. And here you can see all the different volumes which are coming from either the cluster representatives, the point we have clicked on the landscape, or for those regions that we have selected and extracted to a different layer, the center of all those regions. And also we are seeing here a column saying size. This is all the particles that have been associated to a given representative volume here. For example, if we are doing a clustering, this will be all the points contained in a given cluster. For those regions that we have selected, for example, this last volume here, these are all the points that are selected and extracted to a different layer. And this one here, having a size of 5000, correspond to this custom layer we created before, where we just click one specific point in the landscape. And here we are just associating the 5000 closest points to it, and of course the particles that are associated with those points. Let me open the protocol form. And if you remember, at the very beginning, we talked about this advanced parameter here, saying number of particles to associate to the selection, which was equal to 5000 by default. Well, this is the 5000 we are seeing here. So here we have associated the 5000 closest points, which correspond to a given particle, and we can associate the particles to this very specific class. For example, if we click here on block and we click on, for example, class for particles, we can see all the metadata and the particles associated with this very specific class, which can be later on extracted, for example, to perform a refinement or to continue our workflow in many different ways inside Scipion. Let me close the protocol form. Let's right click now on this volume flex output. Let's open it with XMIP. And as you can see, if we compare the classes with the volume, you can see that they are equal. So what we are just doing here is to provide a redundant set with all the volumes, because usually having these volumes outside of the class could be useful for other steps, like for example, doing a refinement. And well, it's a way to have access to this information without the need to extract it from the set of classes. Great, let's close this for now. And as you can see, the protocol here says interactive. What is the meaning of this? Well, it means that if I now double click on the protocol to open the form, instead of restarting the protocol to run it again, I can use the continue run mode, which is by default selected. And if we click on execute and say that we really want to continue the protocol, we can launch it. And now we can start from the step we left our annotation the day before. Great. So now that the viewer has opened, you see that is different to the one we opened at the very, very beginning because it's not empty. We are having here all the layers that we saved previously. And of course, now we can continue from this step and perform or continue the annotation of the landscape. Just to change things a little bit, for example, let's go to our selected points layer and let's remove this layer. We can do this very, very easily by clicking on the layer, making it the active one, and clicking on this button here to delete this selection. For example, let's delete also my custom layer. We can click on it, and instead of using this button, we can click on the backspace on our keyboard, and it would have the same effect. Great, so now let's save this new output, going here to the menu tab. Let's click on Save Selections. Great, it is saved. And now let's close the viewer. Again, a Scipion is telling us if we want to save this protocol output, we say yes. And once the generation of the output has finished, you will be seeing now that we have the first output we registered, which is saved here in case you want to keep it. And now we have a new output that, as you can see, only has 10 items because we have removed the layer coming from the custom layer we created and also this extraction of the points we selected manually. This allows you to generate the outputs based on different annotations that you do and also keep a track of the things that you were doing days before. Okay, with this, we have finished the tutorial for the annotated space, and keep in mind that we have other videos in this tutorial series that you can check to learn all the different tools that we have in Flexutils plugin.